Hi, now we are going to discuss about difference equation and block diagram representation of discrete time systems. Nth order linear constant coefficient difference equation is written like summation k is equal to 0 to n a suffix k y of n minus k is equal to summation k is equal to 0 to m b suffix k x of n minus k. Here ak and bk are real constant. Y of n is output and x of n is input, and n refers, the order n refers to the largest delay of y of n. So this is the linear constant coefficient difference equation. The difference linear constant coefficient difference equation is purely depends upon input output relationship of the system. I told you that x of n is input and y of n is output, and this equation is mainly used to give the relationship between the system. For example, nth order difference equation is given here. This is the nth order difference equation. Now this system equation can be rearranged like this. For example, if you are giving different values to this k, and this summation can be expanded like a, if you substitute k is equal to 0, you will get a naught y y of n plus a1 y of n minus 1 plus a2 y of n minus 2, and it will go up to a suffix n y of n minus capital N, which is equal to summation k is equal to 0 to m pk into x of n minus k. And by substituting different values to this also you can expand, but we need only output. Hence I'm going to take a naught into y of n one side, and I'm going to push other things in the right hand side. Then I'll get k is equal to 0 to m bk x of n minus k minus the remaining part. So I'm going to put this series into summation, that is this function minus summation k is equal to 1, because this k value is starting from 1 and it will go up to capital N. Hence k is equal to 1 to n a suffix k into y of n minus k. Now y of n I can write like 1 by a naught into the rest of the things. Summation k is equal to 0 to m bk into x of n minus k minus k is equal to 1 to n a suffix k y of n minus k. Here the output at time n in terms of present and previous values of the input and output. When you are seeing this, output y of n is purely depends upon the input, present and past input and past output. Okay, if you come across this kind of equation, then the equation is called recursive system, or system is called recursive system. Recursive system is purely depends upon present input and past output. Okay, present input and previous values of the input as well as the previous values of the output. If you come across any system, then it is called recursive. In your syllabus, recursive and non-recursive system equation we have to discuss. Hence, if any system depends upon the present, system output depends upon present input and previous values of the input and the output, then it is called recursive system. Here when you are seeing this equation, y of n is output, present and past inputs are here x of n minus k, and past output is lying in y of n minus k. The procedure for determining the output in terms of input and the previous output is called recursive system output. And we are going to discuss about a special case of this difference equation by substituting n is equal to 0 in the previous equation. You will get y of n is equal to, when you are substituting n is equal to 0, then the past output value become 0, then y of n is equal to 1 by a naught into summation k is equal to 0 to m b suffix k into n minus k. Here the output of the system, discrete time system, is purely depends upon the present and past input. Listen carefully, present and past input. If any system satisfy this property, then the system is called non-recursive system. So this is actually called non-recursive equation. Here the previous output are not required to compute the present output. So we don't require any feedback or previous output to determine the current output of the system. Hence, we can conclude that recursive means the system depends upon previous output. Non-recursive means the system is purely depends upon present and past input, and it does not depends on previous output. With this, we are going to determine impulse response of the system. The impulse response h of n of a discrete time system described by the equation below. So this is the equation, difference equation, and now we are going to substitute um, del of n. Okay, del of n, we are going to replace x of n by del of n and h of n by we are going to replace y of n by h of n. By replacing, we get y of n is equal to h of n and x of n is equal to del of n. We get h of n is equal to 1 by a naught in the summation k is equal to 0 to m b suffix k del of n minus k minus summation k is equal to 1 to n a suffix k into h of n minus k. Here, when you are substituting n is equal to 0 in this equation, n is equal to 0 in this equation, this will go. In the remaining part we have this one. Okay, we have only this one, and this is valid only for specific values of n, that is defined like bn by n naught is defined over this interval, that is 0 is less than n is less than m. So we are going to substitute different values to this k and find out the value of n, because here this is delta function defined only at one time instant. That is, for example, if you are substituting k is equal to 0 in this equation, del of n minus k becomes del of n. Del of n means is equal to 1 when n is equal to 0. So this n and this n are related. When n is equal to 1, when k is equal to 1, automatically del of n minus k becomes n minus del of n minus 1. That means n is equal to 1, n is equal to 3, something like that will go. Hence this equation reduced to bn by a suffix naught when 0 is less than n is less than m and 0 otherwise. So this equation, special case of this equation actually called non-recursive system equation. Okay, now from this we are going to conclude two important system or response for example, two important impulse response. For example, you take this system, this response, impulse response, it consists of finite number of terms. Okay, so this impulse response has finite terms, that is, it is non-zero for only finite time duration. So this system is defined over 0 to m, rest of the thing it is equal to 0. It is only defined over finite duration of time. Hence, this system is called finite impulse response system. Okay, if any system satisfy this property, then we can say that finite impulse response system. If it is FIR, that is shortly called FIR. If it is FIR, then you can say that that system consists of finite number of non-zero elements. At the same time, a system whose impulse response is non-zero for infinite duration, then it is said to be infinite impulse response system. So for example, here h of n is defined over 0 to infinity, then it is called infinite impulse response. With this, we are going to see how to draw block diagram for a given system equation. You know the importance of the block diagram representation. Actually, I'll quickly say the importance of block diagram representation. So pictorial representation can add easy understanding of the behavior and the properties of a system differential equation, and block diagram representation can be easily translated into program for the simulation of system on a digital. We can easily simulate the system when you are drawing, when you are using block diagram representation, and also can be easily and efficiently implemented in digital hardware. This is very important one, and these are the advantage of block diagram representation. So first of all, we are going to represent a block diagram for a system equation y of n plus a into y of n minus 1 is equal to b into x of n. This is actually called first order causal system, first order difference equation. Now we are going to rewrite this equation like y of n is equal to, I'm going to push this term, the second term, right hand side, hence minus a into y of n minus 1 plus b into x of n. If you really want to draw block diagram for this particular equation, we require three important components. One is adders, multipliers, and delay elements. So first we will see adder. Adder is represented using a circle inside this plus symbol. So this particular block will add two signal, x1 of n and x2 of n. Output of this particular output of this particular adder is sum of two input signal, x1 of n and x2 of n. At the same time, if you really want to multiply a constant or any factor, then you can draw a line and put an arrow, and above the arrow you can represent the constant value a. So here input is to this particular multiplier is a, and the output of this particular multiplier is a into x of n, that is x of n is multiplied by the factor coefficient a. At the same time, delay element or differentiation, this is again a box. You can give an input to the box, it will introduce a delay on the input signal and it will produce x of n minus n. These are the three important blocks we require to draw block diagram of a given equation. Now you take this equation. This is the equation which we have seen in the previous slide. Y of n is equal to minus a into y of n minus 1 and p of x of n. So by seeing this, we have an input x of n, output y of n, and delayed version of y of n, and multiplied by the coefficient minus a with the delayed version of the input, and b, a coefficient b with the input signal. Hence you draw you just write x of n in the left hand side and y of n at the right hand side, and first you draw a line, a multiplier line, and just represent a multiplication factor b. Now we require a delayed version of the output and also a multiplication factor minus a. Hence I'm going to take a line from the output, and also I'm going to use a delay element. Output of this delay element is y of n minus 1, and I need a multiplier So I'm going to represent minus a as the multiplication factor. Now output of this will be added with the input. Hence y of n is equal to here. The output of the adder is x b into x of n, and minus plus minus a into y of n minus 1. This is the way we can realize block diagram for a given system equation. So in order to do that, we can use parallel and cascade form. Cascade form is nothing but a block. Subsequently, you can use a block and you can draw it. And parallel form, you need to add these two blocks. Here, I am going to give input to these two blocks using a simple line. From the input is given, the same input is given to two different parallel blocks, and the parallel blocks output is added here. So the response of this system, response of parallel system, can be easily write like h of t is equal to h1 of t plus h2 of t. And in terms of Laplace transform, h of s is equal to h1 of s into h1 of s plus h2 of s. Actually, if you are seeing parallel blocks can be easily added. And feedback path. Here, what will happen if you are giving feedback to the system? For example, x of n is the input and y of n is the output, and we are going to take feedback from the output and we are going to give it to the input, and we are going to find mathematical expression for this particular system. That is feedback interconnection of two LTI system. Now, this case we have two linear time unit system. One is feed forward system and feedback system. H1 of n is feed forward and H2 of n is the feedback. Here H1 of s is the insert transform of feed forward, and H2 of z is z transform of feedback. Now I'm going to represent the error signal E of n, which is the difference between input signal and the feedback, and transform of the error signal is E of z, and z of z is the output of the feedback block. Okay, now with this introduction we are going to write equation. So y of z, z transform of y of n is equal to, so y of n we are getting from this particular feed forward block here, so which is multiplication of E of z and h of z. That is input to the first feed forward block is E of z and h1 of z. Hence y of z is equal to h1 of z into E of z. Now we have error signal E of z. Error signal is determined by the difference by subtracting x of z and z of z. The difference between x of z and z of z. So is E of z is equal to x of z into z of z. We are going to substitute this E of z in this equation. You will get y of z is equal to h1 of z into x of z minus h2 of z into y of z. We need to know what is z of z. Z of z is here. Z of z is equal to the output of h2 of z. So multiplication of the input to this system. Input to the system is y of z. Feedback path y of z and y of z, and the impulse response of the block, that is h2 of z. So z of z, output of the system is z of z is equal to h2 of z into y of z. That we are going to substitute in this equation. You will get this one. Now we are going to multiply h1 of z inside the bracket. You will get h1 of z into x of z minus h1 of z into h2 of z into y of z. Now we are going to separate y of z and x of z. When you are separating, I will get this equation, and by taking y of z outside, I will get y of z into 1 plus h1 of z into h2 of z is equal to h1 of z into x of z. Now I am going to take ratio of z transform of output and z transform of input, that is y of z by x of z, which is equal to h1 of z divided by 1 plus h1 of z into h2 of z. This is a transfer function of the feedback interconnection of two networks. With this introduction, we are going to solve some set of problems. Now just consider a causal linear time invariant system function h of z is equal to 1 divided by 1 minus 1 by 4 z power minus 1. Now we know the transfer function equation. Transfer function is y of z by x of z, which is equal to this function. Now we are going to cross multiply this function. You will get y of z is equal to y of z into 1 minus 1 minus 1 by 4 z minus z power minus 1 is equal to x of z. Just multiply y of z inside the bracket, you will get y of z minus 1 by 4 z power minus 1, y of z is equal to x of z. Using time shifting property, by taking inverse transform, you will get y of n, and inverse z transform of this one is z power minus 1 into y of z is y of n minus 1, and inverse z transform x of z is x of n. That is, inverse z transform of this equation is y of n minus 1 by 4 y of n minus 1 is equal to x of n. Now as we discussed in the previous slide, we are going to write this equation like y of z is equal to x of n plus, that is, I'm going to change the this particular thing to right hand side. So x of n plus 1 by 4 into y of n minus 1. So you can easily draw block diagram of this particular system equation. That is, I am having x of n and y of n. I need a delay element and a multiplication factor of 1 by 4, and I have to add the output of these two things, that is x1 x of n and output from the feedback. By seeing by adding, I will get y of n. So you can even represent this block like plus minus, and but if you are using plus plus, then there is no change here, plus, and this here also plus, then there is no problem. If you are using plus minus, then you have to put a negative here. Okay, so both are same. So secondly, we have another transfer function. So h of z is equal to 1 minus 2 into z power minus 1 divided by 1 minus 1 by 4 z power minus 1. So I can write this equation like 1 by 1 minus 1 by 4 z power minus 1 and 1 minus 2 into z power minus 1. So for this case, we have already discussed in the previous slide. We have drawn the transfer function of this particular system equation, and we need to draw for this one. So I'm just solving this equation like you take this equation h of z is equal to this one. I'm going to write this equation like y by v of z into v of z. I'm just multiplying v of z and dividing v of z of this equation. I'm going to separate this function into two separate function. That is, I'm going to consider v of z by x of z is equal to the first function, that is 1 by 1 minus 4 into z power minus 1, and y of z by v of z is equal to 1 minus 2 into z power minus 1. So first I'm going to consider this equation and I'm going to draw the block diagram. So the same procedure, cross multiplication and taking inverse transform, you will get v of n minus 1 by 4 v of n minus 1 minus is equal to x of n, and block diagram for this particular function is, so I'm going to take v of n and I'm going to push the rest of the other side. So x of n plus 1 by 4 v of n minus 1. So I can easily draw block diagram for this particular equation. That is, input is x of n and output is v of n. So this is the block diagram. Similarly, I am going to draw block diagram for the second equation. The second equation says y of z by v of z is equal to 1 minus 2 into z power minus 1. Again, you have to cross multiply it, and taking inverse transform, cross multiplication, you will get this equation, and by taking inverse in z transform, you will get y of n is equal to v of n minus 2 into v of n minus 1. This is feed forward. Okay, so So this is a forward, okay, y of n, and output is y of n, and input is v of n. Okay, output y of n uh, is the difference between the input and delayed version of the input signal. Hence, you are going to take a link from the input, and you are going to pass via a delay element with the multiplication coefficient -1, and you are going to uh, add these two things and to find out the result. Y of n is equal to sum of v of n minus 2 into z power -1, this one. Okay, now we are going to combine this is the first block and the second block. This is the first block and the second block. When you are combining these two blocks, you will get this one. So this is the first block, and this one is the next second block. Now we are going to combine these two things to produce the output, and by seeing this, we have two common elements. So z power -2 -1 is common to both blocks. Hence, I'm going to combine these two things. Okay, so I'm going to make it single one, and I'm going to redraw the block diagram like this one. So I'm just simply combining these two things, and I'm going to make it one. So this is the block diagram representation of the given system equation. Okay, now we are going to discuss another problem, that is h of z is equal to 1 by 1 plus 1 by 2 z power -1 into 1 minus 1 by 4 z power -1, and we can write this equation by multiplying these two small function into, when you are multiplying these two things, you will get 1 plus this one, 1 plus 1 by 4 z power -1 minus 1 by 8 z power -1. When you are cross multiplying and taking inverse transform that I have given here, h of z is equal to this function, and you have to cross multiply it. When you are cross multiplying, I'm not going to read all the function, so I'm just have a look. When you are cross multiplying, you will get this one, and you have to multiply y of z inside the bracket. You will get y of z plus 1 by 4 z power -1 y of z minus 1 by 8 into z power -2 into y of z, and is equal to x of z. You have to take inverse z transform of this equation. You will get y of n plus 1 by 4 y of n minus 1 minus 1 by 8 y of n minus 2 is equal to x of n. Now we are going to represent this system equation using a block. So in order to represent this particular equation, we need two delay element, because we have y of n minus 1 and y of n minus 2. So we are going to pass the output via two delay element, and we have to multiply with the coefficient to realize this system equation. So the y of n is equal to first you have to take 1 by 4 that is you have to write like y of n is equal to minus 1 by 4 y of n minus 1 plus 1 by 8 y of n minus 2 into x of n. Hence the coefficient of the first delay element output is minus 1 by 4, and coefficient of the second delay element output is 1 by 8. Hence I'm going to use the delay element, first delay element, second delay element, and multiplication factor -1 by 4 and 1 by 8, and I'm going to sum it to produce the output. This is one type of realization. Okay, this is actually called direct form of block diagram representation. Directly we are writing. So in cascade form, we can write h of z into multiplication of two small function. So it's a two small function, and we have to represent small function these two small function into block. So first block is 1 divided by 1 plus 1 by 2 z power -1. So this is I have represented into this block, and the second one I am representing into this block, and we can easily combine these two using cascade form. We can simply cascade these two things. Third one is parallel form. So parallel form, you need to use partial fraction method to decompose your you have to write in terms of, that is, sum of two small um, uh, functions. So I'm going to use partial fraction to decompose the transfer function into small function. That is, I'm writing a by 1 a by 1 plus 1 by 2 z power minus 1 plus b by 1 minus 1 by 4 z power minus 1. I'm going to decompose into two functions, sum of two functions. Now I'm going to cross multiply and I'm going to equate with the transfer function. When I'm equating, I'll get a equation like 1 is equal to, that is 1 is equal to a into 1 minus 1 by 4 z power minus 1 plus b into 1 plus 1 by 2 z power minus 2. Now I am going to consider z power minus 1 is equal to 4. When I am substituting z power minus 1 is equal to, that is, z power minus 1 is equal to 4, then the first equation will become equation will become 0, and I will get some value for the second one, that is 3b. So 3b is equal to 1 and b is equal to 1 by 3. Similarly, so that is, I have to make the first a term is equal to 0, then I have to make b term is equal to 0. If you really want to make a term is equal to 0, then you need to substitute z power minus 1 is equal to 4. When you are substituting z power minus 1 is equal to 4, 4 will get cancelled, that is 4 will get cancelled, and 1 minus 1, then a term will become 0, and you will get some value to second term, that is 1 plus 1 by 2 into 4 into when you are dividing 4, you will get 2, 1 plus 2, 1 plus 2 is equal to 3b. Similarly, you have to, when you are substituting z is equal to minus 2 in this equation, the second term will become 0, and you will get only first term, that is a into 1 minus 1 by 4 into minus 2. So you can cancel this to 1, and also you can, when you are multiplying minus and minus plus, you will get plus. So you will get a into 1 plus 1 by 2, 3 by 2 into a, so is equal to 1. 3 by 2 into a is equal to 1. When you are equating, you will get a is equal to 2 by 3. Hence I am decomposing the transfer function into 2 by 3 divided by 1 plus 1 by 2 z power minus 1 plus 1 by 3 divided by 1 minus 1 by 4 z power minus 1. This is a, 2 by 3 is a, and 1 by 3 is b. Now we are going to realize, draw block diagram for the first one, okay, and the second one, and after that we are going to multiply the coefficients. So here x of n is the input, and it should be multiplied with the coefficient 2 by 3. Then you have to take a feedback, okay, and we have to sum it, and feedback coefficient is minus 1 by 2. Listen carefully. If it is denominator, if you find plus symbol, then you have to multiply with minus 1. That is, if you have plus 1 by 2, then the coefficient value will be minus 1 by 2. Okay, here you have a minus 1 by 4, hence the coefficient value is plus 1 by 4. So second one is second block. First, this block is related to the second equation, and this block is related to the first equation. Now the coefficient of the first equation is 2 by 3. 2 by 3 is here, and 1 by 3 is here. Now we are going to sum output of these two parallel form using a summer and to produce y of n. So this is the block diagram representation of the represents discrete time system. With this, I am stopping my lecture, and we will meet you on some other topic. Thank you very much.